Hello again, this is day 6, evaluating piecewise functions. So we're no longer graphing them today, we're just going to evaluate them. So for example 1, so we're given a piecewise function. I know it's a piecewise because I've got two different graphs going on in there. 2 or more would be a piecewise function. So if I said for this graph, find f of -5, f of -1, and f of 3, that clearly says we're replacing the x with a -5, a -1, and a 3. So when I do that, the question is, well, where do I plug in the -5? Do I plug it into this x or this x? And the answer is, it depends on what the x value is. So here, -5 fits into this domain where x is less than 3. -5 is less than 3, so therefore I would plug it into the x minus 2. So replace the x with the -5. -5 minus 2 is -7. Similarly, the number -1 is also less than 3. So I would plug it into the top equation, x minus 2. So -1 minus 2 is -3. And last we've got f of 3. So I see 3 here and 3 here, okay? But this is where x is greater than or equal to 3. So when I do f of 3, I'm going to sub into the bottom expression here. 5 minus 3 is 2. So in short, when you're subbing in with these, you just have to pay attention to what the x value is and see which domain it fits into. One more example to go here. We're doing the same thing, -5, -1, and 3. Feel free to stop the video and just try it out on your own. But here's the question. So we've got 3 different graphs going on here, and we just have to see again, where do the numbers fit in? So -5 would fit in the top expression, -2x, because -5 is less than -3. And this expression is going to work for all x values less than -3. So -2 times -5 is +10. The next number, -1, would fit into the second expression because -1 is between 2 and -3. So replace this x right here with a -1. 3 times -1 minus 1, and we get -4. Lastly, if I'm going to do f of 3, x is greater than 2 is the domain that fits with this x value, so I'm going to sub it into -4x. And when I do, I get -12. So it's not so bad. You just got to pay attention to the domain that would work best. So let's go to another question here. This says here, is f, that means this function here, is it continuous on its domain? Okay, so continuous would mean that the graph continues on. So in other words, if I was to like draw a graph that looked like this and put my pencil tip down, it is continuous, because see how I can just keep going without lifting my pencil? But a graph that would not be continuous would be something like this. If I trace this down with my pencil, it stops here. In order to pick up the graph, I'd have to go up and over here. So this would be continuous, this would be discontinuous. So how do I know whether or not the graphs are continuous? Well, one of the ways we could figure that out is just kind of going back to what we did in the last video. So let me just go back to our notes from the last video. Remember this example? So you're going to know if they're continuous when you sub in that shared number in the domain, like this one here, and they come out with the same answer. See how this was 3, 3, and 3, 3? And when we graphed it, this is all from the last video, see how they shared that same point there? That's how you know it's continuous. Now, if I look back to the example, the other example we did in the last video, it was this one here. You see how here, the number they had in common, the 0, for example, 0, 0 was one point and 0, 4 was the other. So that is what made the break in this graph. 0, 0 and 0, 4 have a break. They're not the same. So in order to see if these two graphs are continuous, we're going to sub in the 3, that's the number they have in common here in the domain, into both equations, okay? And so when I sub that in over here, 6 minus 3 is 3, and over here, I also get 3. Therefore, they're continuous. And the next example I have, same question, is this continuous or not? We're going to look at, again, all the x values that are shared in the domain. So we're going to look at -3. We're going to sub -3 into this equation, or this expression and this expression. I'm saying expression as opposed to equation because in order for it to be an equation, there needs to be an equal sign, and -2x doesn't have an equal sign on it alone. Neither does this one. The equal sign's over here. And then we'll also look at the 2's because the 2 is shared in this domain here. And if the answers, when we sub in the x value of 2 here and 2 here are the same, it'll be continuous. So starting with the -3, I plugged it into -2x, I get 6. When I plug -3 into 3x minus 1, I get -10. These are not the same number, therefore it's not continuous. Last example, they were the same number, so it was continuous. And then we'll check with the 2 as well. So when I plug in 2 into the 3x minus 1, that's here, I get 5. When I plug the 2 into -4x, that's here, I get -8. It's not the same number, therefore it's not continuous. I cannot, for this example, trace over the graph with my pencil without picking it up, okay? This is our discontinuous example once again, and that's our continuous example. And so that's it for evaluating piecewise functions day 6. The assignment would be this guy over here. Okay, remember this sheet right over here is in Google Classroom as well. If you just look in the stream of the Google Classroom and go up a couple days, you'll see it. Till next time, have a good one.